Welcome, and thank you for joining today's conference, Mitigating Environmental Impacts from Mass Mortality Disposal Operations. Before we begin, please ensure you have opened the chat panels by using the associated icons located at the bottom of your screen. If you require technical assistance, please send a chat to the event producer. You may submit written questions throughout the presentation, and those will be addressed at the end of the call. Select all panelists from the drop-down menu in the chat panel and enter your question in the message box provided and send. With that, I'll turn the call over to Elizabeth Fernandez. Please go ahead.
Good morning, everyone. I'm Liz Fernandez with the Professional Development Services Branch, and I'd also like to welcome you to today's webinar. Our presenter for today is Zoe McManama. Zoe is a hydrogeologist with the Agricultural Runoff Section at the Wisconsin Department of Natural Resources. Introduced to mortality management by the 2015 avian influenza outbreak, for which she conducted field operations, Zoe has since become a composting SME and assisted the North Carolina poultry industry with their recovery from Hurricane Florence in 2018. Zoe currently sits on multiple interdisciplinary and interagency work groups charged with advancing environmental protection through the technical understanding and regulatory application of containment generation, transport, state and mitigation measures in agricultural systems and operations, including Wisconsin's carcass disposal work group in response to COVID-19 depopulations. And with that, I'm going to turn the webinar over to Zoe.
Good morning, everyone. Thank you so much for joining me to talk about this great topic. I'm very thankful to Laurie Miller for the invitation to do this, and I hope I can impart some gems of wisdom to you this morning. So why do we talk about environmental stuff when we start talking about environmental animal mass mortality disposal operations? Well, they're very complex. So there's a whole lot of things that are going on all at once. You've got these challenging sites that are both locationally and aerially diverse. You've got a lot of different materials, different animals, different depopulation processes. You've got contractors, you've got producers, and you've got the general public. And often there are, on top of that, environmental regulations and concerns that make these things a little bit more difficult or more complex. So the goal of this presentation is to give you an environmentally focused tool for your toolbox so that you can get an insight into what environmental regulators and the environmental professional community is looking at when they're looking at disposal operations. So why are environmental issues important? One, because environmental stewardship is valued in the agricultural community as a whole. Secondly, because the operation is regulated, and that may be on several different levels. It could be state, federal, local, and understanding those things. But mostly because environmental impacts from agricultural operations make really big headlines. And this is a problem when there is already stress on an operation due to an event, a mass mortality event. The last thing a farm really needs is bad PR. So these issues can manifest in several different ways. There's the aesthetics, which is going to be what people are seeing, what they're smelling, what they're hearing. There's often a big fear of the unknown with environmental things. Is the disease transmissible, or are there issues with transmission of contaminants? What are the contaminants? Are there human health impacts? Are they going to affect their drinking water wells? Are they going to affect their fishing? There's also disruptions to services and activities. And as we've seen through COVID, people's routines, when they're interrupted, it doesn't work well for many. So the services, both around the farm and for the general public, are often impacted with these. So this all factors into environmental risk. So what I'll talk about here is how you assess environmental risk. Things you can do to mitigate, disrupt, and respond to the environmental issues. how to communicate the risk to stakeholders and the public, and connecting with interagency resources. I'm going to focus primarily on the environmental risk portion of it because it's very important to understand all of the elements that play into that. So for the purpose of this, this talk, environmental risk is going to be restricted to the likelihood that a substance, action, or reaction will negatively impact the quality, quantity, or function of natural resources. I'm not going to venture too far into the human health impacts on this because we just don't have the time to do that. I'm going to focus more on the natural resources portion of it, which in itself does impact humans. So this is the risk diamond that I came up with as I was putting this together. I was like, how can I make this as succinct as possible and as easy and as transferable to every situation that we walk into? And so when we're looking at environmental risk factors, we can break it down into the 4 tenets that we have. So the first one is generation and source, which is where the contaminant is coming from and how it's being made. And then characterization, which is the properties, behavior, and persistence of whatever contaminant is out there. Activation, which is how the contaminant is being released, being moved, or being transported around. And then what receptors are there, which is basically the vulnerable resources or populations. So environmental risk assessments, they really take into account the spatial and temporal generation of risk factors. So it's very 4-dimensional, and this is something to keep in mind when you are looking at a site, is that what you are seeing in that initial assessment moment, you need to broadcast that forward or forecast that forward to see what changes you may see over time. So firstly, generation and source. So we have the types of contaminants that we might see. If a substance has the potential to be detrimental to the environment, it's basically referred to as a contaminant. So we have carcasses or other animal products such as milk, which was a big issue in Wisconsin during COVID. There's manure, both liquid and solid. Leachate, which is sort of broadly any liquid generated by the dewatering or the contact of waters with materials in an agricultural setting. And then wastewaters, which are wash waters or processed waters. On top of that, we also have agricultural chemicals, and on a disposal site, we're likely to have fuels, hydraulic fluids, or lubricants that are associated with the heavy equipment that we're using out there. So these contaminants, what you see isn't always what you're going to get. We have mixing, we have degrading, we have processing, we have handling, which can all change the status of contaminants. So a primary contaminant is going to be those that are readily recognizable when you get on the site. So you walk in, you see your carcasses, you see your manure, you see drums of fuel or hydraulic fluid. They're all going to be primary contaminants. A secondary contaminant is going to be the product of the original form, which is formed through the processing or degradation process. So if you have a carcass that starts to degrade, decompose, then that's going to form a secondary contaminant. A tertiary contaminant is when a product from a secondary contaminant is mixed with another media to form something completely different. And this is illustrated in this particular process. Sorry about the pig upside down. I couldn't find a pig carcass picture that I liked, so I decided to turn a regular pig upside down for distress. We start with the whole animal in the carcass form as a primary contaminant. Now, for COVID, we used grinding processes to deal with the carcasses, which would produce a solid and a liquid fraction. And these fractions would be considered secondary contaminants. Now, with that equipment, you have to wash the equipment. So you'd be adding another liquid fraction to those secondary contaminants, which is going to be a detergent and water, and that would form a tertiary contaminant, which would be separate from what that secondary one would be. This often happened during avian influenza when we were transporting materials around, and so therefore we had to decontaminate equipment fairly frequently. The viricide that we were using was addressing the virus, but not the particulate matter that was generated. So we would have a final product with that wash water that was separate and had different properties than the original virus-laden material that had been in there, or potentially virus-laden. We also have quantity issues. So for decontamination of equipment, the volume of material that's generated or wastewaters that are generated are going to be fairly limited. However, when we start getting into an in-barn situation or a situation that didn't work out so great, we can have large quantities of materials that we need to deal with. This is an example of a in-barn composting operation that didn't go well because the producer was a little bit confused as to how to compost, and he didn't quite understand what was going on. So he did what he thought was right, and it required a little bit of work, to say the least. The liquid that you see on the floor is the leachate that was generated from the decomposition of turkeys in this barn, and it was handled by the addition of more bedding material, in this case sawdust, to absorb that material, and then scraped up and put back into the piles that were rebuilt from scratch and restarted, essentially, at that point. So we were able to contain that. Fortunately, this barn had a clay floor, which limited permeability. However, I mean, barns and the edges of the barns, especially down the running rails, can have gaps. So we kept an eye on where that leachate was being contained. So understanding what's in the material itself is also important. And this can be the chemical constituents, the physical and chemical properties, the environmental and chemical behavior, and how it persists in the environment. For disposal concerns, what we are looking at primarily are nutrients, mostly nitrogen, phosphorus, metals and other elements, and that can be either in the material itself or things that are activated by being in contact with the material that's generated. Different types of pathogens, not just the one that is of interest. Using avian influenza as an example, we were worried about the virus, but we're also worried about other elements such as salmonella. And the effect that would have on things like well water, other watering issues. Pharmaceuticals is an interesting one that comes up every now and then for disposals, and that's especially in groundwater, their persistence tends to be variable. So knowing what's in the materials, especially if you're looking to burial as your disposal technique, knowing how that acts is important. And we also have petroleum products that may be involved, usually when hydraulic lines break. So for physical and chemical properties, these are the basics that we're looking at. pH. So environmental systems tend to be fairly sensitive to pH variability, especially aquatic ones. And we see aquatic systems that react negatively to changes in pH. pH also significantly changes the mobility of metals in the environment. So where we may not have a metals problem previously, if we have a contaminant source, especially in a fluid form, that is contacting native soils that are already high in a metal, it can release those and push them into the environment. For EH, we're talking about the redox potential, which is important for the speciation of those metals and for nutrients, and that affects the bioavailability and toxicity of those metals. For TSS and TDS, so we're talking about total suspended solids and total dissolved solids, so greater than 2 micron and less than 2 micron. TDS comprises primarily the inorganic salts, so calcium, magnesium, potassium, those things, and some small amounts of organic matter. They're pretty important for water quality issues. Relative density is important for how the contaminant is going to behave in the water and the air. So if you have a material that is denser than water, then if it does get into groundwater, it'll sink, which through a profile in a highly fractured bedrock situation, you may not be able to detect it depending on how fast it sinks. And then, of course, we're talking about concentration. You've often heard that dilution is the solution to pollution, and we prefer not to rely on dilution for pollution control. We would rather know what the concentration is and control it. So that's also important to know. So with environmental and chemical behavior, we're looking at the reactivity and how the constituent is likely to behave in changing conditions, and that's going back to speciation again. How is it actually going to show up? Also with stability, so how the chemical is likely to present, and ammonia is one of the good ones, a good example of this. Is it going to be stable? Is it going to be in liquid form? Is it going to be solubilized in water? Or is it going to present as a gas? And when you're doing in-barn composting or in-barn disposal operations, ammonia gas generation in a barn can get to toxic levels relatively quickly. And so we need to be mindful of that. And then again, in mobility, so we have some constituents that are extremely soluble in water and move readily, and we have others that are not soluble at all. So knowing how what contaminant is being generated and how it's going to move around is important. Then we have persistence. So how long things are going to hang out in the environment? Are they going to break down readily and disperse? Are they going to be taken up by plants, or are they going to just hang around and reoccur as problems? And for animal health perspective, obviously pathogens are going to be number one on that list. So Mark Borchardt from USGS has done quite a few virus studies in groundwater, demonstrating that viruses can be very persistent in drinking water wells over time. And he did find some evidence that avian influenza was in the wells around some of the farms in Iowa that he'd sampled. Now, whether it was still active or if it had been deactivated, he was a little unsure of at the time. But the finding it there was interesting from a contaminant control perspective, showing that the pathways, we need to be a little bit more mindful about how things are moving around. Nutrients, again, the persistence of those, whether they're going to be taken upward or not, and then metals and non-metals. So some of you may have seen this before, and in this case, the pathogen survival could be interchanged for contaminant solubility or persistence or toxicity. But when we're looking at the risk and how things are likely to persist in an environment, we also have to look at the risk of transport, how they're being transported around. Because if you have something that is not likely to remain viable, but it is definitely going to move, then you may have a window of transmission that needs to be taken into account. And so a mitigation process would have to come in and address that. On the other hand, if you've got something that is intolerable, if it's definitely going to remain viable in the environment, but it's not going anywhere, then it's not as high a risk because it's easier to control and contain. So that brings us into activation, and what we're looking at here is the contaminant pathways. We're looking at the liberation and the volatilization and the solubility of release mechanisms. For the moving, we're looking at the continuous pathways from point of origin to the point of reception, because that's key. If you have a disrupted pathway, then you have more control over where that contaminant is moving. And then we have the transportation either by another organism such as a vector or a scavenger, or an article like a fomite, a piece of equipment that is transporting things around. So looking at the activation, what is that catalyst for activation? We are looking at generally spills. Things happen by accident. They're unforeseen, and they're difficult to quantify and qualify in planning. So worst case scenario, if I am walking into a barn and I know that there are 20,000 birds in there, I know generally what the water weight of those birds is, and so the worst case scenario for leachate generated by those birds is going to be equal to the maximum amount of water held in those birds. Now, in reality, is that going to be an equal number? Probably not, but that is my worst case scenario that I'm looking at. So we have intentional discharge events. Sometimes we have folks on the site that are unaware of permitting requirements or processes that need to be followed, and so they will pump water from one area to another area and discharge it, land apply it, without being aware that they can do that legitimately. Now, even though that may seem like an accidental spill, it's considered an intentional discharge. Then we have precipitation events, and this is really timely given that we just had a 3-inch rainfall associated with what was left of the tropical storm Cristobal that just came up. It's the furthest north and furthest west a tropical system has tracked so far. And so we're starting to see rainfall events and precipitation events that we haven't seen previously. The patterns are slightly different. So taking the worst case scenario into account when you're making the plans for a site is a good thing to do, because even though it may seem unlikely, it could happen. Freeze-thaw is also a consideration. Unfortunately, not all events happen in when the weather is good, and we do have snow and ice conditions that we need to take into account. This is especially important when you are dealing with partially frozen ground, because you end up with frost perching in the ground, which is when the subsurface is still frozen but the surface is thawed. And so you end up with a preferential water flow that is going to be lateral rather than vertical. And so you may end up with contaminants moving sideways that they wouldn't otherwise. Over-application, irrigation, these tend to be things to do with the disposal of things like liquid manure and manure onto fields, and leaks. When we have either fuel tanks or pipelines, anything like that, as we were talking about before, decomposition does tend to cause activation of things. And then we have contact of waters with primary sources. So the mechanisms that we see primarily are going to be runoff, which is affecting surface waters and land surfaces. Infiltration, which is going for the groundwater, that's going to be that receptor. Wind, which is more of an aesthetic thing, even though we've got concerns with dust and the transmission of viruses. And then vectors. So with runoff, most of it's associated with precipitation, but it's generally overlooked in planning when we're planning sites. And it's a really large piece of the regulatory requirement, as many of these facilities have permits that they're required to control their runoff and their discharge from their sites. So the most common things that we see are the topographic sheet flow, so the movement of water just across the surface, through tiles, swales, ditches, which are all the man-made pathways that they can follow, through streams, and then through anthropogenic preferential pathways such as tire ruts and roads and pathways. When you're out on a site, if you can identify where water would want to go, that will help you plan your site appropriately to contain those discharges. For infiltration, it tends to be a little out of sight, out of mind. The things that we sink in, they tend to be very variable in whether or not they're going to be problematic or not, and what that timeline is going to look for the problems to display themselves. So an environmental professional will be able to assist you in assessing what the permeability or how fast water is going to move through that subsurface, and what that's going to look like as far as moving towards wells or other waters, receiving waters. So prevailing winds and the generation of dust are very aesthetically important. During avian influenza in Wisconsin, there was a concern that the dust generated from the tilling of fields was spreading the virus to farms. Subsequently, after the virus had finished up and we dealt with the farms, one of the producers tested using cottonseed oil and spraying it on his roads and fields as a dust suppressor, so that the dust was not going to blow around as much. And it worked really well. It's a food-grade oil. It biodegrades readily. There weren't any runoff issues that we saw. So there are mechanisms and substances that can be used that are low risk to help suppress those things. The other thing with dust is that if you've got a large site that you're working and a lot of equipment that's going around and the dust is flying, then it can impact both roadways and also the neighbors if they're not used to that kind of activity, or if it's a site that isn't usually used in that way. We're talking about decentralizing disposal operations for pig disposal and putting them in one spot. Is that area usually worked? What kind of changes are you making to those operations that may cause issues? And dust is usually a big one that comes up with people's concerns. Vectors. This is one that was unforeseen in 2015, and it took the form of both insects and vermin. The problems that I showed you earlier in barn composting caused an attraction of flies onto the property, which manifested in the production of maggots, and therefore we ended up with a huge population of flies hatching and multiple generations of them. So not only did they populate the farm, they also populated the nearby lakefront area that had folks that were coming up from Illinois for their vacation homes. And so we had complaints coming into the local health department about flies covering people's cars, and they were concerned that the virus was going to be transmitted through those. Addressing your contaminant sources really quashes the generation of those vector populations from the start. If you can get on top of your leachate issues, get on top of your exposed areas, then you won't have quite the same issues. Again, with some of the operations, making sure that the animals are well and truly covered is good too, not just for scavengers like coyotes and foxes, but also for smaller animals like mice, skunks, and other vermin that get around. We had a mouse infestation in one of the barns too, which I know Melissa Cochran from the Department of Agriculture in Wisconsin was not overly impressed with. It also helps, this is a compost pile that we had reconstructed. This is actually the same barn that I'd shown you earlier that had been covered with leachate, and we redid the piles and put the birds back in. Unfortunately, the birds that had been exposed had already been populated with maggots from the flies that had been attracted. And so regardless of them being covered in the piles, some of the maggots were able to hatch and move out in a swarm, which actually breaks open the side of the pile and moves the pile around, which makes the pile unstable. And so you end up with problems with leachate generation in those areas. So you need to be mindful of those. So then we talk about the receptors. So we've got surface waters, waterways, and wetlands, trout streams, and protected waterways. Knowing those, it really helps your planning on a site, making sure that you can take waters away from those. For groundwater, wells are the big one, but also groundwater exceedances of certain elements and nutrients can complicate matters for farms that are regulated. Specifically, nitrate concerns in, especially, well, in Wisconsin and around the U.S. we have several counties that have elevated nitrates well above drinking water standards, and we don't want to compound that problem for those areas. So making sure that we're controlling nitrate-generating leachates and contaminants is important. We've talked about air and in situ soils, and then, of course, other animals are going to be our receptors as well. So how do we assess all of these things? Firstly, maps. Maps are definitely your friend when going onto a site. If you can get the aerial map, if you can get the NRCS Web Soil Survey map, county GIS can be fantastic. In Wisconsin, we have a few counties that have geological features and wells mapped on those, which makes it really easy for you. Also, the State Environmental Agency and its applicable programs can help join you up with the different areas of the site that are going to be vulnerable or that need attention. So when you're looking at the maps that you're given, these are some of the things that you may want to take into account. High-capacity wells, seasonal irrigation wells, they are going to be very important for groundwater flow direction, and sometimes if they are in a high-density area like this is, they actually reverse groundwater flow. So it can pull water away, back away from its usual path. The location of any municipal wells that are in the area, also vulnerable, also regulated. So they have specific things that they need to take care of. Anything to do with the farm well, if we can prioritize keeping those wells and their surrounding areas clean, making sure that the wells are in good working order and are protected so that they're not getting an inflow of dust or insects or any other particulate matter. And then obviously the waterways and the surface waters, both of which are going to be very visible. And then you have the outside things like mine sites, which are constructed below grade, and so they are another vulnerable area for contamination to go in, which may be airborne or vector-borne. So again, considering both the spatial and temporal locational considerations, so you're looking at your timing, the seasonal variability, your community and industrial facilities, and also the snowmelt and surface water flows associated with precipitation events. Soil types will give an indication of your runoff generation and your suspended sediment loading. For burial, you've got tight clay soils. They can be both problematic and fantastic. They're very protective of groundwater, but they do have a tendency to create a bathtub effect, which tends to form an anaerobic environment for the carcasses, which means that the carcasses don't decompose well. It also, as Doris Olander from APHIS has told us many times, you end up with floating carcasses if you have this situation, especially if you have an inflow of surface waters into the pit. They're infiltrating into the pit, which is adding water, and we end up with bobbing carcasses, and the carcasses raising to the top and cracking through the top. In cases where pathogen control and groundwater protection is really important, then make sure that you've got the right soil types. So if you've got bedrock that is very shallow and highly fractured, if you've got a high water table, you might need to look at the soils a little bit better to figure out those pathways. Remember, any saturated media, whether it be superficial or subsurface, is going to provide a continuous pathway for contaminant for contaminant movement. And that is going to be based, how fast it moves is going to be based on how big those spaces are, and then how soluble the contaminant is in water. So soil and bedrock, very important when you're looking at that. So we've got the highly fractured, weathered, or karsty formations. We also have sinkholes that need to be looked out for. Doing any kind of disposal operations around vulnerable bedrock raises your risk. It can be done as long as it's the generation and the activation and the contaminant themselves are very well classified. But if you've got a receptor like a vulnerable geology, it can move things around very quickly. This is an example of a farm that we have that's actually expanding right now. But this farm is up gradient from a stream system that is in karsty topography. And there's actually sinkholes on this farm. And so if we were to do a disposal operation, having any kind of burial or surface composting would have to take into account the proximity to these open areas, the preferred water pathways that we're talking about. And even though these soils are quite deep in this area, it does have these funky little geological formations that make things difficult. So this is where talking to the local environmental folks will help you out so that you're not inadvertently setting yourself up for a disaster. As I said before, groundwater is probably the trickiest thing to assess because you simply can't see it. We had an oil pipeline break in 32 inches of soil directly on top of bedrock. It was 100 feet down to the water table, yet we were seeing impacts to wells half a mile away within a day because of the pathways that oil was able to take, or that petroleum product was able to take down through that unsaturated media to the water table and then just shoot down the fracture zones. So taking that into consideration, if you had a similar situation with a process that generated a lot of leachate, you could have a similar process with the leachate migrating down through, finding the water table and shooting very rapidly into somebody's well. So it's always good to keep in mind. Well construction data is not always useful for us. It depends on what aquifers are being utilized for water production. There may be multiple aquifers, shallow ones, middle ones, deep ones. They all have different constituents and different behaviors. I talked a little bit about perched aquifers from frosting, especially in thaw times. That also happens around hydric soils, where we've got pans, hard pans that have developed in highly calcareous or silicious soils, or we end up with those what we call argillic horizons, which is just basically a clay layer that is going to keep water above it. That may not show up in well construction data, and so it's going to be something that in the field, if you see an area that is unusually saturated or forms a depression or holds water or, yeah, just is different, that may be something that might be a factor there. Springs and groundwater recharge areas are especially sensitive and should be avoided. They're hard to pick out a lot of the times, and again, that's where your local environmental folks are going to be able to help you out. The one question that you might want to ask is, have there been any issues with well contamination previously, either from manure spreading, or if they have well quality issues? Do they have high iron, high manganese, arsenic, nitrates, any kind of issues? Because these can be indicative of a groundwater system that is very reactive and you have high permeabilities. And those pathways are present, which means that you're going to have to be more protective in how you're constructing things. So again, putting it all together, what you're looking at is, do you have the potential for contaminant formation? What are the contaminants' properties, and can they change? Can they move around or be transported? And what are your vulnerable resources? These are the things when you're walking onto a site and you're taking a look at it. These are the environmental questions that you are asking. So, again, know how the weather might affect your site. It's going to be difficult, but always err on worst case scenario. It'll help you mitigate a lot of things. Minimize your disturbed area. Limit your traffic. If you have traffic, think about putting in tracking pads before they hit the road so that you're not tracking material from the site out onto the road, which again causes issues for runoff and for aesthetic problems. And thinking about the material handling and storage, getting your operators to be tidy helps a lot with managing vectors. And always assess. See what's being generated and where it's going. For structural and engineering controls, limiting your contact, deflecting water away from things, covering vulnerable areas, minimizing your surface areas, constructing secondary containment so that your runoff is being held in one spot, avoiding your ponding and disrupting long runs for water flow to reduce energy. And that may be as simple as running a plow around a top slope to deflect the water away. It doesn't necessarily have to be a big undertaking. It can just be something simple like that, or a row of straw bales well placed can also work. Do the routine maintenance. Make sure the leachate is being controlled. Filling ruts, again, limiting your preferential pathways. And also identifying your breakpoints or your limits. How much is too much to be generated on a site? You can have a little bit of leachate coming out of a pile, but at what point does that become problematic? Understanding that. So having a spill or release plan, most operations should already have one. You might need to expand on that a little bit depending on your operation. Contact the environmental agency to see what their requirements are for reporting spills or discharges off the site. If we do get a large rainfall and the disposal operation is severely impacted and causes a discharge. And then have a triage plan for your vulnerable resources. What are you going to need to protect first? If there is a large flooding event, is there a well that's going to be impacted potentially? Things like that. So for communicating your risk to the stakeholders and the public, preparation and documentation really helps, because if you can show folks that are showing an interest a map and what's going on and where things are going and how materials are being handled, what precautions you're taking. Just addressing those fears goes a long way to limit those environmental risks. Also giving them a point person for contact if they see a discharge that they're concerned about, if there's a dust issue, if they're experiencing a higher than usual amount of vectors, whatever. If they have a point person that they can contact, then that assuages some of those fears. So interagency resources, partner with your environmental agencies as soon as possible. They know the regulations. They have some resources, depending on how they're funded, and they can definitely help you with planning. Most of the environmental agencies have been through discharge events, significant ones, and they are aware of where the weak points are and can help you identify those. So if you have any questions on environmental assessment or risk planning, feel free to contact me. Here are my contact details. And yeah, I look forward to your questions.
And with that, we do have a couple questions in the chat. What effect does poultry foam have on groundwater?
Okay, so there was concern with firefighting foam and PFAS, which has been widely spread. So the foams that we have been using in the last few years have shown to not have PFAS in them. So we're not worried about that element. In the basic way, firefighting foams, or poultry foams in this case, are surfactants, and they break down fairly readily in the environment. They do tend to absorb to clays, and then they just kind of get broken down by bacterial action over time. They're not overly persistent, and for the most part, I haven't seen any detrimental or adverse reactions to poultry foams as they're incorporated into composting facilities.
Okay, we have another question. Are there recommendations for preventing insect swarms for controlling or dispersing them once they've started forming?
Yeah.
Fly swarms were a big problem during HPAI.
Right. So the things that we found that were the most effective were addressing the leachate issues that were forming at the toes of piles as soon as they were happening. And then for the flies, really making sure that the birds or animals in the piles are well covered. And if the maggots are pushing carcasses out of the pile, making sure that they're buried well back in the pile so that the heat generated by that pile can deactivate them. They're really the two things. Using any kind of fumigation, you're probably going to jeopardize bacterial action in composting piles that you don't really want to do, so probably want to limit that. Although the fumigants won't go all the way into the pile, it's just generally something we stay away from because it will get reworked into the pile on turning.
Okay.
But yeah, fly swarms are a big problem. Just if you can contain the problem and have a plan for how you're going to address those different issues ahead of time, it goes a lot smoother.
Okay. Do we have any other questions in the verbal queue?
Ladies and gentlemen, if you'd like to ask
property.
Sorry, ladies and gentlemen, if you'd like to ask a question, if you can please press #2 on your telephone keypad.
Okay. Do you know if you can compost on tile property? Yeah, we generally don't construct composting windrows over tiles. Just like land spreading or any other activities, we like to stay away from those preferential flow zones just to limit the exposure and limit the risk. So knowing where your tiles are and knowing what that pathway is going to look like, it's pretty important. So if you're talking to the farmer when you're planning things, if you can map out where the tiles are and stay away from them, great. Otherwise, you're bumping up your risk.
There's another question in the queue. How far can fly forms travel? Yeah.
Well, the ones that we saw were going within a mile radius of the farm. They weren't going too far away from where their food source was that we could see. That's the only experience that I've really had with them. I could ask a insect person.
All right. Are there any questions in the verbal queue?
There are no questions in the verbal queue at this time.
Okay. And I don't see any questions in the chat. So on behalf of the National Training and Exercise Program, I'd like to thank Zoe for presenting today. And thanks to everyone who attended the webinar. The NTEP will be offering a webinar on June 16th at 11 a.m. on the National Veterinary Services Resource Ordering process. And as always, if you have any ideas for webinars that the NTEP can explore for our emergency preparedness community, please feel free to contact us. And you can find recorded webinars on various topics on the TEP video gallery online at the USDA APHIS website. And with that, I'd like to tell everyone, have a great afternoon,